Well, good afternoon, everyone, and welcome to today's Epicenter Psychosis Speaker Series. I'm delighted to introduce our distinguished speaker today, Dr. David Kimhy. Dr. Kimhy is an associate professor and director of the Experimental Psychopathology Laboratory and program leader for new interventions in schizophrenia in the Department of Psychiatry at the Icahn School of Medicine at Mount Sinai. He's also done some amazing work here around exercise interventions for people with schizophrenia that we'll get to hear about today. And if I'm correct, has currently 2 R01s funded looking at exercise interventions in this population, not just around physical health, but around suicide and cognitive outcomes around here too. So exploring how these interventions and the benefits from them here may really extend beyond the more direct physical health benefits that we might see here. I became most familiar with his work as I think he published the first paper I ever remember seeing on mobile digital assessments among individuals with schizophrenia. Then it has now become an area that has just blossomed and boomed here. So I always remember, I believe it was a 2006 paper that you know, in my mind was sort of the kickoff for, I think, what's been a movement about that. But he's obviously moved beyond that to new and exciting things as well here too, with exercise interventions. And I am excited to hear about this. As always, we'll have a Q&A at the end of today's session, and questions can be sent to me in the chat for that. But with that, I'm delighted to turn things over to our distinguished speaker today, Dr. David Kimhy. Well, I think you're still on mute there.
Okay, can you hear me?
Yes, now I can hear you.
Great. Thank you very much for the kind introduction. It's really a pleasure to come and talk about our work and share it with people that I know we share a lot of interest with in my group. So it's a pleasure to be able to do that. Before I start, I'll just make sure that I'm able to move this. Okay, here we go. Just financial disclosure and current funding. I don't have any conflict of interest. All my funding is NIMH these days. So I'm going to talk about neurocognitive functioning in people with schizophrenia. And I'm sure many of you know people with schizophrenia display a broad range of neurocognitive difficulties. And while the primary focus of research in schizophrenia and interest in schizophrenia, obviously it's on the psychotic symptoms, it's more those cognitive difficulties that have been identified as major determinants of poor functioning and disability. There have been extensive research in this area. It's been documented in multiple studies. This is a example from our results from a study by August and colleagues. So it's a fairly typical results in terms of cognitive functioning. So you'll see the dark bars. This is a performance on the matrix consensus cognitive battery, which is one of the most commonly used batteries for cognition in schizophrenia. So the dark bars are healthy individuals. The white bars are individuals with schizophrenia, and generally, most studies found that people with schizophrenia score between 1 to 2.5 standard deviation below the mean of healthy individuals. So not tests like the MCCB, these are T-scores, so healthy individuals will score around 50 on average. People with schizophrenia score anything from 40 to 25. And this is a kind of across the board, so you see different domains of the MCCB. So you have processing speed, vigilance, working memory, etc. So, now, given that these deficits play such a central role in functioning, there's been a lot of interest in trying to develop interventions over the past 20 years to target this cognitive deficits. The 2 primary areas or strategies that have been used thus far is pharmacotherapy and cognitive remediation. So in terms of pharmacotherapy, people try to use the 1st and 2nd generation antipsychotics, which were not designed to improve cognition, and not surprisingly, they're not. They showed very limited efficacy in terms of improving cognition, and actually for some patients, it makes their cognitive functioning even worse. Patients, report about side effects, about feeling groggy and tired, and so that doesn't help their functioning. About a decade ago, there was an initiative by NIMH to try to expedite some testing of pharmacological compounds that some pharmaceutical companies had. This project was called TURNS, and it was an initiative by NIMH with pharma and some leading academic centers to try to kind of test, in an expedited process, some of those compounds. So it was a quite large study, 7 sites, and making long story short, there was basically none of the compounds that were tested that showed any benefits. So unfortunately, no magic pill in terms of improving cognition. So, in terms of cognitive remediation, this strategy provided some more promising results, although the benefits have been modest and there's quite large variability in terms of treatment responses. Some studies showed really exciting benefits, on others not so much. For example, with a fairly large recent study that had about a fairly large 150 patients undergoing quite extensive training. So this is several times a week, 1 hour per day for 6 months, and looks like they were not able to show any cognitive benefits. I think there's one of the challenges is trying to find some of the active ingredients of what is it that in cognitive remediation that help produce benefits, and there's actually quite a bit of work looking into that these days. Now, but still, that kind of leaves us with a situation or with position that there remains an urgent need to identify novel approaches for development of treatment targeting neurocognitive deficits in people with schizophrenia. And when you talk about neurocognition, I want to talk about the neurobiology, and enhanced neurocognitive functioning is related to the brain's ability to modify neural connectivity and function. So this neuroplasticity is dependent in part on a family of proteins in the brain called neurotrophins, which are heavily involved in signaling neurons to survive, differentiate, and grow. And in particular, one member of that family, a brain-derived neurotrophic factor, which is the most abundant in the growth factor family, and attracted a lot of attention because it has a wide repertoire of neurotrophic and neuroprotective properties. And germane to schizophrenia, from studies that BDNF is lower in individuals with schizophrenia, including among drug-naive patients. And it seems like not to be impacted by age or duration of illness or degree of psychopathology. The depletions in BDNF are been identified in multiple brain regions, so it's not localized. And there's some evidence that suggests that it's linking it to poor short-term memory and smaller hippocampal volume. So based on this, it looks like BDNF upregulation may be a good candidate mechanism for improving neurocognition in schizophrenia if you can upregulate it. And so this has kind of got us, this is something that we started working about 10 years ago or so, and we got interested in that and looking at sort of what can upregulate BDNF, and one activity that is known to upregulate neurotrophin in general, and BDNF in particular, is aerobic activity. And in fact, among neurotrophins, BDNF has been found to be the most susceptible to upregulation by aerobic exercise, with the synthesis and release into blood circulation increasing in a dose-response manner. So more intense exercise, the greater the release of BDNF. In terms of exercise, there's extensive literature from animal studies that support the positive influence of aerobic exercise on neurocognition. Basically, it does a lot of good things in the brain, multiple regions. Among humans, by the way, I think that photo is photoshopped. I hope for the guy it's photoshopped. But again, there's similar extensive literature that support the positive impact of exercise on neurocognition. This is in adolescents, young adults, older adults. There's also literature in children, school-age children. And this is the benefits are kind of a multiple cognitive domain. So generally, there seems to be kind of converging animal and human research literatures that support the positive influence of aerobic exercise on neurocognition across the mammalian lifespan. Now, when we talk about physical activity, again, going back to people with schizophrenia, I'm sure many of you know, many of our patients tend to have a very, very sedentary lifestyle. A lot of our patients don't do much in terms of physical activity. They're in fairly bad physical shape, and generally they spend most of the time doing very little physical activity, if any. So when we got interested in that a few years back, our first goal was trying to see, well, can we first confirm that people with schizophrenia have low aerobic fitness, and then to see whether that relate to cognitive functioning. So we developed a study to look at that. So we assessed aerobic fitness using this is considered a gold standard, looking at VO2 max, which is essentially an index of how efficiently people use oxygen as they face a challenge. This is similar to the type of test that you do when you go to your cardiologist to do a stress test. This is just kind of a fancier version of it. So the test involved people sit on this electromagnetically brake cycle ergometer, which is a sort of a fancy computerized stationary bike, and we connect to both measures of oxygen use and as well as heart rate, looking at cardiopulmonary functioning while they do it. And the procedure is they just sit there initially for 5 minutes and then just pedal for 3 minutes with very low resistance, and then the resistance is kind of computerized to the program to increase every minute. So which result in the effect of something equivalent of climbing up on a steep hill. So you do it for about 12 minutes. The whole procedure takes about half an hour, under half an hour, and then there's a recovery period of about 3 minutes. And we look essentially how people use oxygen as they face this challenge. And this is considered a gold standard of aerobic fitness. So when we looked at the data, we compared, this is a study that looked at 32 individuals with schizophrenia and 64 age and gender matched healthy controls. Not surprising, the people with schizophrenia had substantially lower aerobic fitness. Just for a reference here, so most healthy individuals will have an average VO2 max of around lower 30s or so. Somebody is active, they probably have higher 30s, lower 40s. Somebody has exercised regularly will probably have higher 40s, and professional athletes will have probably 60 and above. So in our study, the people with schizophrenia, the healthy individuals scored around 30, the people with schizophrenia scored around 22. With some of the lower scores, actually the lower score was 12. So someone with a score of 12 will have major difficulties climbing upstairs like one flight. And if you look at the distribution of the scores here, essentially we had just 6% of the participants with schizophrenia scoring 30 or above. These are the dark shaded lines at the top of the schizophrenia column. So again, this wasn't used. We just established here that people with schizophrenia indeed have very low aerobic fitness, and our next step was looking at to what degree does that relate to cognitive functioning, and we looked at it two ways. We looked at neurocognitive functioning as looking again at the MCCB, and then the other measure we looked at actually daily functioning using the SLOF. So the slough is a survey that you administer both to the patient as well as to an informant. Usually it's a family member that sees and knows the patient very well and sees them at least on a weekly basis. There are various domains there. And aerobic fitness was highly correlated to both total cognitive functioning composite score on the MCCB as well as the slough total score, and this is controlling for depression and antipsychotic medication indexed by chlorpromazine equivalence. So based on this study, we kind of took the next logical step and said, well, if cognitive functioning is related to aerobic fitness, well, maybe we can increase aerobic fitness and see whether that kind of trickles down or translates to cognitive improvement. So we did a single-blind randomized clinical trial. It was a small pilot study. These are our main outcome measures. This was funded by a generous grant from NIMH. Our exercise protocol, well, the hospital I was working at the time had a fairly modest facilities. This is definitely not Equinox or any of the Reebok clubs. So basically we had a modest size indoor basketball court, as well as attached to it, there was a small gym space, and the gym space had a couple of treadmills, a stationary bike, an elliptical machine. Again, fairly basic equipment that you'll find in most gyms today. One concern we had about using this equipment is that, well, running on a treadmill can get old very quickly. So we're concerned about patients getting bored, and we're trying to think of ways to kind of make it a little bit more interesting. And the way we came up with is using active play video games. So this is Xbox Kinect. And then using, this is an off-the-shelf technology, and also using a package of exercise games. It's called Your Shape Fitness. Again, you can buy it in any game store. The software has about 30 or so exercise games, about half of them aerobic. And so the way the system works is, you have the TV, you have the Kinect, which is sort of like the device there that you see, which is essentially a fancy camera. And what it does, it scans the person as they stand in front of the TV and create an image of them or an avatar and place it inside, I guess, the virtual environment. And as the person is moving, the avatar is moving simultaneously. So if the person is jumping, the avatar is jumping simultaneously. There's no delay. The person is lifting their arms. The avatar does the same. So essentially, you can interact with a virtual environment and with objects there as well. And maybe for those of you that are not familiar with this, maybe the best way is to kind of demonstrate this. So this is one of the games of this, that we use. It's called Wall Breaker. So essentially, the person would stand in front of the TV. This is what they'll see as they, oops, go back. So this is what they'll see as they start to exercise. The game is loading up. So the task here is to punch the ice boxes.
Welcome to Wall Breaker. If you're in a fighting mood, you've come to the right place. Perfect wall breaking.
Okay, as you can see, so again, the image of the person, would be the avatar. It shows them actually quite accurately. And the task here to engage the boxes, to break them. So essentially, the person will stand in front of the TV and essentially punch the air, but aim to break the boxes. This is interval training, so the games are typically between 3 to 5 minutes each. They're personalized. Individuals sign up to have an account, anonymized in this case. They get credits. The degree of difficulty here is increased as people go from level to level. You can really get your heart rate running with this. I have it at home. I used to play with it with my daughter. It's really you get a really good exercise from this. Essentially, it's gamifying the notion of exercising, and it's making it a little bit more fun. So typically, in an exercise session, participants will come and we'll do a warm up with them with a trainer, and then they'll pick what exercise equipment they want to use. So they'll maybe do 15 minutes on the treadmill, 15 minutes on the elliptical machine, 15 minutes on the Xbox. So they get some variety of different experiences. And part of the reason we change it is so people have kind of a different muscle group, different muscle tone experiences. Everybody wanted to use the Xbox naturally. So that was the other reason to kind of have people change stations as you will. So, let me go. All right. Now, one of the other things that we were concerned about is intervention fidelity. And looking at the literature, even today, there's very few studies that actually report data on intervention fidelity, which the main issue with that is that it really makes it hard or difficult to compare studies that have divergent results. Now, most studies, when they do report some intervention fidelity, they typically report the percentage or the number of total sessions attended. And as many of you may know, like going to the gym is very different than actually exercising. I mean, I think we all been there. One thing we try to do is also capture not only whether people showed up, but also whether they actually engage in session. The way we did that, again, using sort of off-the-shelf technology, this is a Polar watch with a chest strap that records heart rate. And we designed a program based on federal guidelines that participants need to, the first week, exercise at 60% of maximal heart rate, which was based on the VO2 max test that we did at baseline. Then week 2 is 65. Week 3 is 70, at week 4 and to 12 is 75. Just to give you a bit of a sense of 60% of maximal heart rate is basically being able to engage in physical activity while still talking. So you're not so much out of breath that you can't talk. So it's not very intense. And we programmed the monitors, the heart rate monitors, to emit a beep if participants' heart rate was lower than the individually targeted aerobic exercise intensity for that week. And when that happened, usually the trainer would go and kind of try to cheerlead them and try to help them make sure that they sort of stay within that window. And typically that window was whatever target heartbeat they had for that week, plus minus 5 heartbeats. So results from the study, we published a few years on a paper in Schizophrenia Bulletin. So just first, in terms of kind of intervention fidelity, our attended participants engaged in 79% of the sessions they attended. And then within the session, on average, the participants' heart rate during the sessions was 25% of the session time across people across the 12 weeks. Intervention was between 60 to 69% of maximal rate, 27% between 70 and 79, and so on. On average, the participants' heart rate was below the minimal in 60% that we indicated, only 11% of session time. So we had a very high intervention fidelity because we could look at sort of what percentage of session times people exercise at their target intensity level. In terms of results, so this figure shows the association between changes in aerobic fitness and changes as indexed by VO2 max, and changes in neurocognition as indexed by the MCCB composite score. The diamonds in blue are the aerobic exercise people. The control intervention here was just treatment as usual. The correlation was 0.54, so modest, moderate correlation. And then in terms of head-to-head comparison, so you have here the dark blue bars are aerobic fitness, the light blue bars are cognitive functioning. So not surprisingly, the aerobic exercise group increased their aerobic fitness quite a bit, actually 18%. On the other hand, the treatment as usual group has like a virtually no change, modest decline. And in terms of cognitive functioning, the aerobic exercise group increased their total score on the composite score of the matrix by 4 T-score points versus a small decline in the treatment as usual intervention. And just kind of a reference here, sort of what does this change mean? If you recall, I said in the first slide that most patients with schizophrenia score between 1 to 2.5 standard deviation below the mean in terms of cognitive functioning compared to control. So a change in 4 T-scores is equivalent between 16 to 40% reduction of that deficit. In this particular study, it was 24%. So essentially 12 weeks of aerobic exercise cut the deficit by a quarter, nearly a quarter, which is quite impressive. In terms of the BDNF, again, we did a hierarchical stepwise regression analysis, and we found after controlling for a host of variables, changes in aerobic fitness significantly increase upregulated BDNF by nearly 15%. Now, since we did our study and published it, there's been a number of other studies looking, so our results are not unique. I mean, again, you can see this is a meta-analysis by a review by Joe Furt, looking at exercise studies and neurocognition and schizophrenia, and generally the results suggest a small to medium effect size for the impact of aerobic exercise to improving cognitive functioning. Our study is the fourth one from the top. And one of the things that we wanted to look at is sort of what is it, the active ingredient here in terms of the exercise characteristics that seem to drive improvement. So we looked at fidelity with the target training intensity. This is again the window whether people exercise every week. Frequency is the frequency of sessions. Duration is the total time that participants exercise over the 12 weeks. And what we found, it's actually sticking with the percentage of time people exercise in that target window was highly correlated with cognitive improvement. Obviously, this is a very small sample, just 13 individuals, but the correlation is 0.7, so looks very promising. More recently, we started looking at whether, so looks like there's benefits for cognitive functioning, but to see whether there's a benefit extends to other cognitive domain, including social cognition, social functioning. This is a paper just published a couple months ago at the end of 2020, looking at the impact of exercise on social functioning. In this case, we looked at 3 indices of social functioning by self, informant, and clinician-reported measures. Self is self-report, informant again is the SLOF. Clinician is as part of a clinical interview, and generally it looks like the changes in the VO2 max, or aerobic fitness, accounted for 47, 33, and 25 percent of the variance respectively of these measures. Again, this is controlling for a host of control variables, including demographics, medications, symptoms, and social networks. We recently, since this publication, started looking at whether there is, we can try to figure out what is it sort of that drives this improvement in social functioning. This is a work that is still in development. We have not, so this is not peer-reviewed, but it looks like the social functioning improvements are driven primarily by improvement in emotional awareness, or alexithymia, the ability of people to label their own emotions and describe them, and by improved emotion regulation, which is a decreased use of suppression. And those two variables were the primary drivers of improvement in social functioning. So this would suggest, definitely for the alexithymia part, that this is essentially kind of a bottom-up improvement in social functioning. Based on these findings, we applied and received a funding for an R1. This is for essentially trying to replicate our results in a much larger sample. Our original sample had 30-something patients, so it was just kind of a proof of concept. The study is currently ongoing. It's a multi-site, single-blind, randomized clinical trial. We compare aerobic fitness. In this case, the control intervention is stretching and toning, which is it's pretty much equivalent in any way to the aerobic exercise without the aerobic component. It's a 4-year study. We hope to recruit 200 subjects. We have 4 sites at Sinai, at the UNC, Stanford, and Augusta in Georgia. Interventions is 12 weeks, 3 times a week, 1 hour with a trainer, similar to the previous protocol. Mean outcome measures also very similar. And again, this is supported. This is a study that I'm a co-PI with Scott Stroop from Columbia. Right now, we actually, one challenge that we had, obviously, is with COVID and everything that's happening in the past year, exercise and the heavy breathing that involved in it is actually kind of quite a bit of a risk factor. So we had to stop our protocol. We were restarting it. However, we're going to actually change it. The plan is to have people exercise at home with iPads and sort of online trainer that kind of has a 2-way video audio connection. We're kind of very excited to see how that's kind of going to work out. But that's kind of one of the challenges of doing research there of COVID. For those of you who are interested in kind of more the mechanics and logistics of how exactly we're designed and what we're doing, we published a grant report. This is a couple of years ago that has all the details of how we organize the study. So you can look there. Also, just before the COVID pandemic started, we received a supplement to look at whether the exercise benefits suicide risk in this population. And the rationale was that exercise improves cognition, but also depression and sleep. And these are all 3 kind of predictors of suicide risk. So we receive a supplement to look at that. So we add suicide risk measures to our protocol. Again, the mechanics of logistics of that protocol, there's a paper published late last year. So kind of summing up the benefits of aerobic exercise. So at this point, there's quite a strong evidence that it's improved neurocognitive functioning. There's some preliminary evidence that it's improved social functioning in people with schizophrenia. It's generally very safe, nearly side effect free, non-stigmatizing. I think this is really critical. A lot of our interventions that we do are stigmatizing, whether it's medication or psychotherapy, even cognitive remediation. On the other hand, exercise, everybody does exercise. It's actually kind of cool. Everybody did exercise. There's no knowledge that you need to have to acquire to do it. It's relatively inexpensive, and it's relatively easy to administer. One major advantage compared to other interventions is that provide multiple physical health benefits in addition to the psychological, psychiatric benefits, and that's something you're not going to get from cognitive remediation, and definitely not from medication. It can be conducted in indoor using limited space. In our case, this is our focus was using kind of, again, a fairly modest gym. And again, it's supported by extensive converging animal and human research literature. I think one thing critical is about this work is that low aerobic fitness is one of the few modifiable risk factors for poor cognitive and social functioning in people with schizophrenia. We don't have a lot of those, but we can change low aerobic fitness. This is not something new. Actually, this is in Europe. The European Psychiatric Association published guidance that physical activity should be incorporated into standard treatment. They provided a major meta-analysis and review as well as a white paper. And I can here just to quote on that. Our comprehensive review provides clear evidence that physical activity has a central role in reducing the burden of mental health symptoms in people with depression and schizophrenia. So this is for severe psychopathology in general, not just schizophrenia. Our guidance provides direction for future clinical practice. Specifically, we provide convincing evidence that it is now time for professionally delivered physical activity interventions to move from the fringes of healthcare and become a core component in the treatment of mental health conditions. So this is definitely a very strong argument. I think in the US, we're still sort of interventions for exercise are definitely recommended. It's still not been codified in that way. I think there are one of the challenges for this is actually in terms of payment by insurance companies or federal government. Right now, this is not reimbursable. There are in recent years, some attempts by some insurance company to encourage people to exercise, so they'll provide Fitbit or some similar devices, but that's not similar to as a reimbursable payment for treatment. And then probably until that happens, we're not going to move this into kind of a mainstream component. Now, I have a few more minutes, so just before we finish, I want to kind of maybe take a step back here, kind of, and look at things a little bit from the 10,000 feet above ground kind of perspective, and thinking about. I've been spending a lot of time thinking about exercise and their plasticity and their condition, and thinking why should there be a link there? And the notion that exercise should improve cognition, it's not a straightforward notion. I mean, I think if you have kids and you want them to excel, academically or cognitively, you probably tell them read a book or do a puzzle. You're most likely not going to tell them to go run jog around the block. This would not be a first choice, but given the evidence, the question is how come there is a link? And the notion that exercise and neurocognition are related, actually the notion of exercise in general, it's a fairly new notion, probably something that hasn't developed, or used broadly for the general population until the late 18th century, early 19th century, and so forth. So, but if there is a link, so this is probably something that kind of goes further, much further back. And if you think back about our ancestors, The only times people typically, or ancestors, ran or engaged in physical activity is whether they're chasing some animals or running from animals. So there's a question whether there's a kind of a evolutionary link that links cognition with physical activity. And then there's some very intriguing suggestions that this may be the case. So this is a work by an anthropologist, David Kimhy, and he's found an association between brain size and maximal metabolic rate, which is a proxy for exercise capacity. And as you can see, it's this is across a wide range of mammals. And when he looked at humans, kind of our closest relatives, great apes and hominins, this relationship is even stronger. So there's essentially aerobic capacity is closely related to brain development. And essentially, if there is this link that is supported, by evolution, I think any kind of intervention that would essentially use that link or build on that link, I think that's a kind of a good starting point. I think in terms of our population that we're dealing with, I think that's definitely a case because many of our patients tend to be very, very sedentary. So, I'll stop here and thank you for your attention. And if there's any questions, I'll be happy to answer.
Thank you, Dr. Kimhy. We've had a number of questions already come in the chat, and actually, since I was just talking, a new one popped up after that. First question. The results of your studies are impressive. What are the practical implications for coordinated specialty care programs to promote aerobic interventions? Should we provide access to video exercise programs or develop space within our sites to provide access to these programs?
That's an excellent question. Actually, I think in some way, people with schizophrenia and severe psychopathology are much better positioned to benefit from exercise than people with sort of less severe psychopathology. Because I mean, if you think of an example of somebody who has like an anxiety or depression, they probably typically treated in private practice. And so if they want to exercise, they have to kind of go on their own and find a gym and pay membership and engage on their own. On the other hand, people with schizophrenia and more severe psychopathology, many of them are treated on community mental health centers or clinics. So developing programs via those clinics, I think it's like it's much, much easier. And in order to do this, I mean, I think you don't need, it's not rocket science. I mean, it's fairly easy to do that. We focused on active play video games because was our way to kind of make it interesting. And the advantage is also you can do it indoor. It doesn't take a lot of space. Essentially, you can run it in something like a large community room that is typically available in many clinics. And essentially, this equipment you can move in and out from storage. So that's something that is definitely doable. I think in terms of considerations, and again, that would not cost too much. I mean, but in terms of considerations, I think one thing that you want to do if you're listening to this and you're like, oh, this is exciting, I want to develop a program like that, is you want to first have your patients undergoing physical, because a lot of our patients, again, are very sedentary. You want to make sure that they are able to exercise. And especially you have people that may have sort of high risk. So if you have somebody whose BMI is 45 and they're smoking and they have diabetes and there's a history of heart disease in the family, I think you want to be careful with those individuals and you want to make sure they're clear to exercise by a physician. The other thing that if you do is you want to start, we use the strategy of start low and go slow. So you start very, very slow. My interest in this work came from working with one particular patient that sort of was very, very sedentary. and I was trying to have her activate a little bit, and initially asked her to. We agreed that she'll walk. This is in New York, so she'll walk around her block one time a day, every day, and she agreed to do that. She did it for 1 week. That works nicely. The next week we increased it to 2 blocks, so going 2 across, coming back 2, and again. So essentially, what you want to design here is an intervention that is almost kind of fail-proof. At least initially, you want to create a track record of success and then increase intervention intensity over time. As far as equipment, I mean, we use, our equipment here, but you can do this actually without any equipment. You can go walking exercises or, jogging. The challenge with that is that depending on weather, that can maybe be a limiting factor. So if you live in Texas in August or, in Wisconsin in February, I think it's going to be a challenge to exercise outside. So this is sort of the rationale for using the strategy we use. You can do it anytime. So I think, and the last factor, I think I would highly recommend getting a professional trainer, somebody who's certified, somebody that has background with treating clinical population, training them. I know sometimes there may be a temptation to think like, hey, my RA is pretty athletic, they're going to the gym, they can run it. I think you want to take somebody that actually is essentially a professional. So.
Great. The next question, what are your thoughts about whether type of aerobic exercise has differential impact on cognition? For example, I wonder whether the Xbox games might have greater impact on cognition than treadmill or bike or elliptical, given that participants have to follow instructions and remain cognitively engaged to complete the exercise.
Absolutely, that's an exercise. That's an excellent question. We suspect yes, and this is something that we actually figured out after we started, that if you look, for example, the exercise, the wall breaker that we did has some elements of go, no go test. Essentially, you have a stimulus and the person has to respond and make a judgment. You have to kind of punch up or down or kick. So there's a decision there, and then there's an interference, the pendulum. So we very quickly kind of realized that there's obviously a cognitive component there. I'm not aware of any studies that look at it. I mean, that if somebody want to do the study, I think that would be a great study, sort of doing straight up treadmill versus something like this. I would be very curious about the finding, but I suspect there is some benefits.
So the next question is, my son has schizophrenia and does well with jogging while using different playlists. Mm-hmm. Is there any research relating to the effects of music with the aerobic activity? Also, can you share the online training website where you had success with during COVID?
I'm sorry, I didn't hear the last part of the question. Can you repeat it?
Oh yeah. So the first question is there any research relating to the effects of music with the aerobic activity? And the second part is, can you share the online training website you've had success with during COVID?
So for music, I'm not aware of any studies looking at that. There's quite a bit of research there looking at various interventions. Again, I mean, I see there's nothing unique about, I think, Xbox. It's just it's kind of way to make it fun. And I think we all have a challenge of kind of trying to get ourselves to the gym, and anything that makes it a little easier and more fun, I think it's helpful. So if it's Xbox, it's one thing. If it's music, that's great. I think it's more kind of a vehicle to improve engagement. As far as the website, we actually, it is not a website. We hired, there's a startup company that specialize in online cardiac rehabilitation, that they developed this device or program that they can run exercises kind of with a two-way video and having kind of live heart rate for the trainer to monitor. So unfortunately, that's not something that is available publicly.
Okay, the next question is, can you explain the link between exercising and increased emotional awareness?
We're still thinking about that. I mean, that's kind of what's a bit puzzling. We're interested in that because actually we have another line of research that shows, emotional awareness, alexithymia, is highly predictive of social functioning. So it was a bit of a surprise to see that this is the pathway that it sort of operated with. I'm not clear for myself. This is still something that we're kind of scratching our head and trying to kind of figure out. How does that related? So unfortunately, I don't have a very good answer for that.
Okay, the next question is, were you able to gauge people's motivation to partake in exercise? As a clinician, the biggest barrier we face is having people practice skills beyond the lab, given the deficits in motivation that may accompany psychosis.
Absolutely, that's a major challenge. I think most of the people that came to our trial were not interested in cognition. They just saw it as an opportunity to exercise. Essentially, the way we sold it is that you get the equivalent of a 3-month, 12-week gym membership with almost personal trainer. The exercise sessions typically had one trainer and 3 or 4 participants at any day, or sometimes even less. So essentially, they had, that was the kind of, I think, one of the primary selling points. Obviously, participants received payment for the research assessment. We provided reimbursement for transportation expenses for the research and exercise sessions. So, so I think that's the kind of the primary way to go. And obviously, I think the Xbox, I think that was a selling point, and once people started with that, I think that was a fun thing to do. I think that is a challenge. But again, I mean, I think if you're planning to engage patients, you want to initially try to design it in a way that it was going to be very, very hard for them to fail. So in my case, I mean, the example of walking around the block, I mean, it's hard not to do that. And I purposely, even though it was less than what that person was able to do, I initially started with that because I wanted to create a track record of success and saying, hey, this is work, you're doing great. I think serving as a cheerleader. I think the other thing too is, there's a lot of talk about shared decision making. This is one of these, I mean, having conversation about the potential benefits. And again, exercise is one of the things that improves a lot of things. Improves mood, improves health, improves cognition, and social functioning. So it has a lot of benefits. It's one of the few things that actually improves so many things. So it's a really something that I think patients can see and understand and hopefully get motivated to do.
Okay, next question that came in is there any link between physical health and cognitive decline prior to the onset of psychosis? Should we be considering exercise interventions in clinic serving people at clinical high risk for psychosis?
Absolutely. Actually, we have a paper that's very close to being published, likely, that's looking exactly at that, at the aerobic fitness and aerobic activity among clinical high risk. This is with Vijay Mittal and some people in his group. I think we know even among clinical high risk individuals, they tend to be the sedentary behavior and the cognitive difficulties are present even in that population. So I think this is something that definitely, I think it's one pathway to the future, because I think the advantage of doing it with this population, first, I mean, they may be able to relate to Xbox and sort of similar strategies, kind of much more than older population. And also some of the comorbidity, especially the physical comorbidity, is not quite there yet, versus what you see in kind of more older patients with schizophrenia. So I think that's definitely one direction for the future.
Great. Well, thank you, Dr. Kimhy, for a great talk here today. Oh, one more question just came in. We'll squeeze it in under the wire here. How fast does walking have to be in order to be of cognitive benefit? Is measuring it by heart rate a benefit for the individual being asked to walk?
So, I mean, we use the standards of about 60% of maximal heart rate. So that means if somebody has a maximal heart rate of 200, their target heart rate should be around 120. And again, I mean, for most individuals, doing 60%, they should be able to talk and while walking. So it's intense, but they shouldn't be out of breath enough. And again, because it's a dose-response relationship, obviously the more intense, the better. But also you want to, especially with people that are just starting and they're very sedentary, you want to take your time, make sure that starting with a 60%, that's or even lower if you need to, that should be sufficient. So,
well, Dr. Kimhy, thank you for a wonderful presentation here today. And thanks everyone for joining us this week. Next week, we'll have Don Addington presenting on Fidelity measurement for coordinated specialty care. Hope everyone is staying well and healthy and enjoying hopefully the better weather that everyone is getting these days here. And we'll look forward to hopefully seeing many of you next week. Take care, everyone.
Thank you.